Hello students, today's agenda is to check homework. You will be doing some exponential transformations and you will be able to work on 8.13. Students will be able to sketch the graph of exponential transformations as well as identify the asymptote. So if we have y equals 4 times 2 to the x, first of all, I would like for you to understand or relate this to previous lessons. And remember that this is your initial point, which is always kind of like the y-intercept basically. This is the base, which tells me what to do with that initial point. So in here it says multiply by 2. Okay, for each cycle, multiply by 2. And since we have it to the power of x, it means like every one. Okay, so the sketch for this would be something like this. Okay, so my initial point is at 4, so 1, 2, 3, 4. And then it says double it. Okay, times 2 means twice as much, so double it. So for 1, double 4 would be, and it's just gonna be a sketch. So at first I kind of marked the 1, 2, 3, 4, but after that I'm just gonna put the values. So for 1 it would be at 8. For 2 it would be double that, so it would be at 16, and so on. Okay, so for 3 it would be 32, but I can't go that far. Okay, so now what if I have, and I'm kind of gonna use the same graph. For 4 times 2 to the x, but I'm going to subtract 3 in this case. Let's see, I'm finding some colors. And so basically it's going to be this same graph. However, another thing that I want you to know is that eventually this is gonna go to 0. Okay, so if I subtract 3, that means my, like, every point is gonna go 3 down. Okay, so let me see. Instead of 4, it's going to be at 1. Instead of 8, it's going to be at 5. Instead of 16, it's going to be at 13. So something like that. Okay, same thing. You know how this line right here, it converges as x goes to the negative infinite, it converges on y equals 0. Okay, so that's called the asymptote. Asymptote is equals to 0. However, for this one, all the points are going down by 3, so also the asymptote is gonna go down by 3. So for my new line, the asymptote will be -3. Okay, so again, this is gonna be my line. Whoops. And it's gonna converge when y is equals to -3. Okay, now what if I have y equals 4 as the initial point. I'm doubling it every cycle, but I'm going to add 1 to the grand total. What that does is that it's going to go up. Every point is going to go up by 1. And so it's my asymptote. So my asymptote is going to go up by 1. Okay, so asymptote is equals to 1. Okay, and that's for this for number 3. Let me color code it. This is number 2, and so my graph will actually be this one right here. And I know it's a little hard to see because of how close they are actually. Okay. Okay, if you take a minute to copy it, maybe pause the video. Okay. I'm gonna draw again. Well, let me draw the first one that we had, which is the kind of like the base that we have. Okay, and so it's, again, we start at 4, which is my initial point. It doubles every cycle. Double 8 is 16. So double 4 is 8, double 8 is 16, and double the 16 will be 32. So maybe, let me see, maybe I can just include it in there, 32. Okay, so my graph, my original graph is right there. Remember, this is my initial point. It tells me to double it or multiply it by 2 every cycle. And this means that the asymptote would be at 0. So basically it means that this curve will converge at 0 as x goes into negative infinite. Okay, so now what if my transformation is y equals 4 times 2 to the x plus 6? So when we're talking about exponents, when we're adding, it's gonna move to the left, and if we're subtracting, it's gonna go to the right. Okay, so in this case it will move to the left because you're adding 6 to the exponent. So you might want to put a little note in there. If we add to exponent, left. If we subtract to the exponent, then we go to the right. Okay, it's kind of like the opposite. Sorry about that. If we add to the exponent, we're going to move every point to the left that many spaces. If we subtract to the exponent, if it was minus, then we would move it to the right. But in this case is addition, so we're going to move it to the left. So how many spaces? It's going to be 6 spaces in here. This is for the third cycle, so it's going to be 3 and 3 more. This one is going to be 3, okay, 1, 2, 3, 4, 5, 6. This is going to be 1, 2, 3, 4, 5, 6, 6 like in here. 1, 2, 3, 4. Yeah, kind of like that. Sorry. And then 6 in here. So something like this. The asymptote, if you notice, when we add or subtract, the curve is just going to move to the left or to the right. So the asymptote is not going to change when we move left or right. So basically my line will be something like that. So again, my asymptote is also 0 when we do the transformation and we're adding or subtracting on the exponent. Okay? The asymptote is gonna stay the same. Okay, take a minute to write that. What if I subtract 6? Okay, let's do another one with, yeah, hopefully it can show. You know what, I'm gonna do it in this same graph, but with a different color. So, for number 5, I'm gonna write it in here. I was gonna write it there, but my graph is gonna go right there. Okay, 4 times 2 to the x minus, should we do minus 6 or minus 5? Let's do minus 5. Okay, and so this point is going to move 5 spaces to the right. I'm just going to sketch it. It's not going to be perfect. Another 5 in here. Another 5 in here. 5 in here. Okay, and again the asymptote stays the same. Okay, so my graph is gonna be a little like this. Okay, again the asymptote also stays the same because it's just moving to the left or to the right. It's not moving up or down, so the asymptote does not change. Okay, again, remember, if we add it, then it goes to the left. If we subtract, it goes to the right. So basically the opposite, right? Okay. Take a minute to pause it and take note of this. Now I want you to sketch y equals 4 to the x. And so this is a little bit different because you don't have the initial point. You just have